Alright, so here's the question in question. Let's say you are a varsity basketball coach and you've got 15 players on your roster, but you need to cut 3 of them. It's an unfortunate event and tears will be shed, but it's a decision you need to make. And you wonder, how many different ways can I cut 3 players? Well, that's the idea of combinations. It doesn't matter who you cut first. It just matters that you're picking from a group 3 players to cut. So it's important that we're picking from a group and that order does not matter. So let's try to think about this problem. Pause your video and see if you can come up with an estimate of how you would how many different ways there are to cut 3 players. Assuming you've paused your video. Well, let's say we wanted to choose 3 players with ordering them. So, we've got 15 different players. That's the first one that we're choosing. There's 15 different ways to choose the first player. Then there are 14 different ways to choose the second player. And 13 different ways to choose the third player. So that's the first cut. That's the second cut. Whoa, I cannot. Apparently I don't know what the number 2 looks like. That's your second cut, and that's your third cut. Now, of course, it doesn't matter how many different ways we can arrange those 3. So what we need to do is divide out the number of ways to arrange 3 players. So we're going to divide by number of ways to arrange 3 players. Well, that is actually 3 factorial. So we can take this whole denominator and substitute it with 3 times 2 times 1. So in the numerator, we've got the ways to choose 3. So that is permuting 3. But we don't want to order them, so we divide by 3 factorial to get rid of the order. So in the previous problem, what we were looking at was n choose k. And the formula here looks a lot like the permutation formula. So in the numerator, we have n factorial, and we have n minus k factorial, but we need to get rid of the order, which shows up here, with k factorial. So this part gets rid of the order. And this part on the left side, that is n permute k, where order matters. So we permute k. We permute 3 students that we're going to cut, and then we get rid of the order because order doesn't matter. So let us look at an example. Let's suppose you've got 20 students, and that we're going to choose 4 of them for a field trip. So what we need to consider is that this is a combination. We don't care who gets chosen first or second or third or fourth. So we're going to do 20, choose 4, which is 20 factorial over 16 factorial, 4 factorial. I'm going to throw that in my calculator really quick. And that gives me 4,845 ways to choose 4 students. So let's consider how to do this on our calculator. So what you're going to want to do first, if we're trying to do 20 choose 4, we're going to put 20 in, then math, then scroll over to probability, then we're going to do NCR, and then we're going to press enter. That will give us 20 NCR, and then we put in 4, enter, and we will get the correct solution. Let's consider a couple of example problems, and then I will let you go for this video. Let's suppose you are looking at 60 different cars and you want to buy 2 of them for your family. How many different ways are there to do that? Now, it's really important to realize here, order doesn't matter. Same thing for, let's say you're looking at 85 teams and you're going to choose 5 of them to give a humanitarian award. Once again, order doesn't matter, so we can use combinations. So, pause your video and try to come up with a solution. Alright, assuming you've paused your video, let's take a look at the first one. That's 60 choose 2. That's 1,770 ways we can choose 2 cars. And the next solution is 85 choose 5, which is going to be a significantly larger number. So yeah, there's a lot of different ways we could choose those 5 teams. So here's a lovely little extension problem. Let's say we're going to choose 5 classes, but you need to pick 2 English, 1 math, and 2 sciences. And let's say there are a total of 10 English classes. There are 10 English classes to choose from. Let's say there are 5 math classes to choose from. And let's say there are 7 science classes to choose from. So this is a bit of a tricky problem. We're going to combine a couple of different elements here together. Pause your video, try to answer to the best of your ability. Alright, so let's consider these individually. So the number of ways you can choose your English class is 10, choose 2. The number of ways you can choose your math is 5, choose 1. And we should be able to do this one in your head. If you've got 1 class to choose and you've got 5 options, well, 5, choose 1, there's 5 ways to do that. That should make sense, I'm hoping. Maybe. Maybe not. I don't know. And let's consider our science. And all of a sudden I'm forgetting how to spell science. My goodness. That's 7, choose 2. So on your handy dandy calculator, we're going to skip the weird math and just get right to the solution. That's 45. That's 21. So now if we're considering the total number of ways, now we're going to use the counting principle. Woo! So our number of ways would be, the number of ways we can choose an English class is 45. Number of ways we can choose the math class is 5. The number of ways we can choose a science class is 21. This is similar to picking out your outfit. Really no difference here. So we look at 45 times 5 times 21. That's going to give us 4,725 different ways that you can choose your classes. Isn't it amazing? There's just 22 different classes offered. Look at the amount of ways that you can select these classes. It's pretty awesome. So ladies and gentlemen, here ends our combinations video. Up next is using Venn diagrams to figure out new problems. So up to this point, if you've mastered everything, you're at a 3. but you're going to need to use the techniques in the next video to get up to a 4. So we're going to look at next, we're going to look at Venn diagrams for complex counts. Woo! I'm excited. I don't know if you are. Yeah, this is going to be great. Wonder what video wonder what song I'm going to sing at the beginning of the next video. Well, this coffee is certainly delicious. That is some delicious coffee. I'm excited for this Venn diagrams video. Let's do it.